After 5 amazing years of Unity development and a ton of C# wizardry, it's time for a change. After surfing the web, forums, and talking to ChatGPT, it is time for a new engine, the Flax Engine. Hosting a ton of useful features and an amazing resemblance to Unity, it is the most likely candidate to take its place. Forget Godot and Unreal, and let's take a look at the Flax Engine. Hello guys. So on the previous tutorial, we did the movement, the mouse look, and the camera follow. And on this tutorial, we are going to continue with shooting in the mouse direction and projectile collision. So to get along with it, let's get back onto the player script, and we are going to start coding immediately. Let's add here a header for everything shooting related. So we go shooting. And we're going to need to spawn something. So the way that we spawn something is that we are going to need a public prefab so that we can spawn prefabs. So projectile prefab. We are going to need a position where this prefab will be spawned from. So we go public actor spawn point. We are going to need a public float fire rate, which I'm going to go at 3. So this is going to be the projectiles per second. Okay, cool. Because I like to do my shooting in a state machine way, we are going to have to add a couple more variables. So let's get down here, and we're going to go float, and we are going to go to fire delay and fire time in cooldown. All right, so we are still missing our states. We are going to mark those states as an enum. So we can go here and we can add a shooting state or fire state, as you prefer. Okay, let's delete everything. Let's go public enum. And so the states that we're going to have is idle, where we are waiting for input. Then we're going to have the shooting state, where we spawn the projectile, and we are going to have the cooldown, where it's just cooldown. Let's fix this up, and let's beautify. All right. Let's go back to the player script and let's add here the shooting state. All right, awesome. And so let's create here the void handle shooting. And let's have here a switch statement where we are going to have our shooting states. It already knows. Let's add the missing cases. And for each of these states, we're going to have a different method. So let's go void shooting state idle, void shooting state shooting, and void shooting state cooldown. Let's go create the behaviors first, so you know what's happening. So on the idle states, we are waiting for inputs, right? So if input, we want to get the mouse button and not mouse button down or mouse button up. Because this way we are always checking. And if we just check for mouse button down or mouse button up, it will only check once. This way we're checking every frame. So you can either insert the index of the button, or we can go onto mouse button and go with left, which is pretty nice. So what is going to happen when we have our shooting inputs on the idle states? Well, of course, we want to change to the shooting state. And we do this by creating a change state method. So we go void change shooting state. So we go shooting state, target state. And here if our current shooting state is equals to target state, then we of course want to return. We don't want to do anything, we are already in that state. So shooting state if else, we are going to change the current state to the target state. Right, so let's go here and change the shooting state to shooting states dot shooting. So here on the shooting states, we want to spawn the projectile, right? So right now, since we don't have any projectile, even though we have there the variable, we're just going to debug.log, and player has dropped, or player has fired. All right, so once we have done everything we need to do with this, then we can go ahead and change the state again to shooting state dot cooldown. So what is going to happen in the cooldown state? We are going to increment time, and once that time is greater than the shooting state, then we are going to go back to other states. So let's take a look at it. So time, what did I call it? So let's take a look at it. So fire time in cooldown equals time dot delta time, and if fire time in cooldown is greater than fire delay, we can go ahead and change shooting states to idle. You know what? This fire time in cooldown is a little bit confusing, so let's just call it time in cooldown. All right. So what is going to happen is that when we are in the idle state, we are waiting for input. Once we have input, we fire immediately the projectile, and once we have fired, we enter the cooldown state, which will then, once it's done, it will go back into the idle state, which if we still have our input pressed, then it is going to repeat the loop again. Else it's just going to stay here, which is awesome. So something that I also forgot is to reset this every time we enter the cooldown state. So if we are not going to use the switch statement because we are only looking for the cooldown state. So if shooting state equals cooldown state, then time in cooldown is going to be 0 because we just entered it. All right, nice. So here we can add our shooting state idle, shooting state shooting, and shooting states cooldown. And of course, let's not forget to add this up here on the update function. So let's check if we aren't missing anything. I don't think we are. We are missing something. So to calculate the fire delay, we have to make a very simple calculation. We go fire delay equals 1 divided by fire rate. And in case we want to change this while playing in the editor, because this only changes on start, let's also change this back up once, back down, sorry, to when we try to change a state. Okay, this way we can iterate on our changes and see them real time in the game world. Okay, let's take a look. So if we click, let's go to, as you can see, it is firing. So let's start the projectile thing. All right, so first we need to add a fire position. So let's add, even though I wanted to add like an empty game object, let's instead add here a tiny sphere, which doesn't have collision, if you remember, so no problems. And let's scale it to 0.5. Sometimes it's too big, 0.2. Well, 0.2 is good. Okay, let's get back up. And good. Okay, this is about right. Let's change this to spawn point. And now let's add the projectile. So to add the projectile, we're going to create a new empty game object, which we are going to call projectile. Let's pull this bad boy a little bit up. And let's add a capsule. Let's rotate this capsule on the x-axis by 90 degrees. By 90 degrees. Let's also scale it down to 0.5. Okay, that's good. And let's decrease it on the z-axis, minus 25 maybe. Okay, sounds about right. So, projectile model. Let's also go to our resources and materials and create a material for the projectile. Let's create a yellowish color. Okay, let's not be too picky. We can add it to our projectile. Okay, so how do we make this projectile a prefab? Well, if you remember with the walls, we can just drag and drop it to the projectile folder. We can now delete it. We can go onto our player. We can select the projectile, either by here or by dragging and dropping it over there. And then we are going to need our spawn point. All right. We now need to make some modifications in our code where in the shooting state, instead of just debugging the has fired, we will now spawn a projectile. So how we do this? We go actor, because the thing that we are going to spawn is going to be an actor. And we go, we do not go like projectile prefab dot instantiate. That doesn't exist. Instead, we go prefab manager dot, we will go with spawn prefab since we only have a single scene. And then we go projectile prefab. We need to set its position. So it's going to be on the spawn point dot position and its rotation or orientation. So we go spawn point dot orientation. It's not rotation, it's orientation, even though here says rotation. Let's take a look. So as you can see, we are creating our projectiles, but they aren't moving. So let's get them rolling. Let's get back onto our scripts folder. Let's create another folder, call it projectiles. Let's add a new script, projectile. And on this projectile, let's delete what we do not need. And this projectile is going to need a few variables. So public float speeds. Let's give it a 15 speed. Don't forget that this is in centimeters. And let's give it also a lifetime, public float lifetime, about 1 second to live. So we need a float time alive or just time, and we can go into this. So we can go on override updates. And how are we going to move this projectile? Unlike our player, it doesn't have the rigid body. So how are we going to move it? The actor component has a really nice function called add movements, and it is basically the translate function in Unity. So this is what we are going to use. So we are going to get the actor's forward position. So we go actor dot direction. We can get and set the forward direction. Another way that we can do this is by going to actor dot transform dot forward. Okay, but I'm going to go with direction. Times speed times time dot time. Let's not forget that this is in centimeters. If you want to get it to meters, you multiply it by 100. So we haven't added this script to our projectile. So let's open up. Let's go to here. Let's add the projectile. We have it here. Let's save. And let's get going. As you can see, it is creating the projectiles. They are being spawned and they are moving. All right, that's nice, but they aren't being destroyed because we didn't set up the lifetime. So the way that we do this is we go time plus equals time dot delta time. Wait, what? Time dot delta time. And if time is bigger than lifetime, then we want to destroy this actor. Okay, let's take a look. As you can see, they are being destroyed now after 1 second. Okay, awesome. So we have a projectile that just moves. Currently, it doesn't deal any damage, it doesn't collide with anything, and we need to implement that. So let's go public int damage, and let's give it a damage of 1. Let's also beautify this a little bit. And let's organize this to void handle movement and void handle collisions. So this now goes into the handle movement. Okay. And in the collisions, we are going to do something a little bit more orthodox. I am going to use a physics.overlap instead of having a collider because this guy has no collisions. And what we are going to do is to add an invisible box, but instead of being a collider, it will be a physics.overlap. And to view this box, here's what we're going to do. We are going to go override on debug draw. This is the same as Unity's on draw gizmo. And what we are going to do is we are going to we are going to debug draw dot drawbox, and this is asking us for a lot of weird stuff. A bounding box, a color we are familiar with, but bounding box not so. So let's create a bounding box. Bounding box equals new bounding box. If we take a look at it, it is really strange, but we have here some parameters we can change, which is awesome possum. So let's get back to our script and let's go box and edit the parameters. Center is going to be our current position, so go actor.position, and the size is going to be something that we haven't set up. So we need here to add a public vector3, and let's call it hitbox size. And for now, it's going to be a vector1 times 10. I don't know. Since this is in centimeters, I have no clue what is what. Size equals hitbox size. Alright, so let's add here our box. Let's give it a color. Something awesome that Flax has is a ton of unique colors, and I really like this blue-violet one, so let's go with it. So if we are back, let's add the projectile here so that we can check the gizmo in real time. So it seems that our gizmo is too small. If you check here, now we can see, I think it was about 30, 50. Okay, so this is the box that we are going to use to check the collisions on our projectile. But this is a draw box. Let's draw a wired box. This way we can check the inside. It will only draw the outlines. All right, nice. So let's get back onto the collisions and let's handle the collisions. So we can go physics.overlap box. This is going to need a center. Like this, we are going to use the actor.position and half extends. This is actually half the size of our hitbox. So let's go hitbox size times 0.5. This is the same as dividing by 2, but it is a little bit more performant. And we are going to need an array of colliders. So let's go colliders equals this, and we are going to go out colliders. This is going to spew out this collider result onto here. Right, so we are also missing a rotation, which is going to be our actor.orientation and not rotation. Okay, so now we have two options. We can either check if this array is bigger than 0. So if colliders.length is bigger than 0, that means we have had collisions. But because this already this already gives a boolean, let's instead set this inside, inside the if statement. All right. So if this is true, we want to do something. So for int I.collider length, let's debug. debug.log hit collider plus collider.i. And of course, once we are finished with everything that we need to do with the colliders that we have collided with, we want to destroy this actor. Okay, let's give it a check. As you can see, it is destroying. If we check on the debug, you can see that it is destroying. And another very useful thing that we can do with this physics box, with this physics.overlap, is that we can change the layer mass at runtime, we can change the size, we can change everything. It is very customizable, we have more control, we can call it when we want, we don't have to call it every time. So I prefer this rather than the trigger enter and collision enter and stuff like that, because this also allows to detect more than one collision if such thing happens, and I just find it more flexible overall. Alright guys, now that we have finished the shooting mechanism, in the next tutorial we are going to start the preliminaries of the enemy AI and how to deal damage. So stay tuned, like and subscribe so you don't miss out.